Let's move on to our next keynote presentation, and now let's put things into motion by warmly meeting Professor Antanas Cenys from the Information Systems Department at Vilnius Gediminas Technical University, or as it is called now, Vilnius Tech. He's going to share a presentation about machine learning on the edge. With a round of your virtual applause, let's invite him on the stage. Tai dabar, kai baigėsi šitas.
Hello, everybody. I am very glad to be here, and I am thankful for organizers to inviting me, and especially I am thankful for all speakers who made their presentations before, because it makes my job much easier. I should not speak about machine learning anymore, or at least to explain what machine learning is. But I still have some task to explain what edge is. And is it any difference for machine learning in general and machine learning on the edge? So I was trying to find on internet, like everybody, every student is doing, what is a definition of machine learning on the edge. And the best I was able to find was that machine learning is technique on smart devices to process data locally, using the same algorithm and reducing need to come to some central server, or nowadays everything central is more or less cloud. So speaking generally, edge is something about architecture. So let's have a small picture, and I'm taking all my pictures from scientific literature. Maybe they are not of the best quality, but they are scientific. So what do we have and what we call edge? Edge is a number of devices, usually what we call Internet of Things, which are sitting on the edge, and so making all, I would say, measurements, data gathering. And they transmit their data somewhere, sometimes directly to the cloud, sometimes to some local server or local device, and where the data is processed. Okay, so I like this picture very much because it shows some kind of machine. It can be in the cloud, or it can be in the internet edge device, in this case sensor or node, you can call as you like. So somehow the question is where we are putting our mind. As a human being, we are saying that our brain is in the head. And that is natural. But this is not natural always. In our nature, we have some creatures which does not have one brain, which are having more brains, and they are not necessarily in the head. So, and I have a nice picture of octopus. Octopus has 9 brains, 1 brain in every arm, and 1 brain in the stomach. I like very much putting brain in the stomach. I think this is very reasonable. But anyway, it demonstrates that where we are putting our brains, it's up to us to decide. And so the question, where we are making our brain or machine learning or artificial intelligence whatsoever, it depends on some reasoning, which depends what we want, and we should find the way to do and say why we are doing that. So the question we can put, why machine learning is moving to the edge? The simple answer is because it can. Because our devices, just mobile phone nowadays is the best personal computer from 90s or even later. So the device is becoming smarter and smarter. And so the data which are collected by these devices or sensors can be processed at the sensor. Should it be? It's another question, but for sure it can. So one clear idea is that we can do it. Okay, so how many different architectures do we have? So since we can put our machine learning, or I am now using the term machine learning as same as the brain. Yeah? We can put it everywhere. We can put it in sensor. It can be on the local edge server, or we can communicate in the cloud. Usually, and what was talked today, there are mixed architectures. There are some sensors, some preliminary data processing done locally, and some are transferred to the cloud. In this picture, what is also important, that machine learning has different stages. So one, to learn, we need to train our system. So the first question, where this training is happening? It can happen on the node, it can happen on the edge server, or it can happen on the cloud. On the other hand, when we have the system trained, we can use it for making inference or decisions. Because what we want from the trained system, when the system is receiving new data, to make some inferences or to make decisions how to behave. So where this is done, again, is up to us. Okay, so cloud machine learning versus edge machine learning. Why? Because typically machine learning, usually we assume that it started from the big machines, supercomputers, and nowadays supercomputer is cloud. Cloud is having practically unlimited computing resources. Cloud is able to gather unlimited number of data. And we can scale it easily. Cloud is very reliable. So naturally, this new wave of machine learning, because machine learning technology is very old, but nowadays it's becoming everywhere, and this new wave started with the cloud computing. But if we are doing everything on cloud, we have some issues to be solved. First of all, despite all this 5G, 6G, and so on speed of internet, there is some latency. It will take time for information or data to travel to the cloud and come back. And the point is that, as usual, the more powerful network do we have, the more data we are able to generate. So latency is unavoidable. On the other hand, if all the data we are transferring to the cloud, it will cost us as a bandwidth. One can imagine how much data every new self-driving car will be generating. It will be a lot of data. And to transfer everything to the cloud, it will take time and it will cost. There is more here. When we are doing our training on the cloud, we are assuming that the whole data is homogeneous. But if we are going, let's say, back to the same example with a self-driving car, maybe the driving is often happening at some street which has some pot and some old lady every weekend is appearing on it. And you cannot catch these details if you are training on all self-driving cars. Okay, so edge machine learning. Okay, as I told, it's more or less like real inference. It is much closer to the data, it is faster. The data is local, we don't need such a big bandwidth, and what is much more important, if we are processing data locally, it is much easier to deal with privacy. It's up to us what to transfer to internet or to cloud and what to leave for ourselves. Of course, we are paying price. The edge devices, by definition, we are having much smaller computing resources. And amount of data which can be gathered is also limited. And again, the bandwidth, we need limited one, but it can be costly. If we need to use mobile devices and so on, it can be costly. On the other hand, privacy is easier to deal with privacy. On the other hand, security, on the cloud, we can hire best specialists. For the local devices, it's not so obvious. Okay, so I want to switch now to another, I don't know, architecture or method of edge learning or computer learning. This is called federated machine learning. This is quite new stuff. It appeared just a few years ago, but I think that this is the most promising technology when we are speaking about machine learning on the edge. What is this? Or how it compares with distributed machine learning? Distributed machine learning is when we are sharing our learning capacities between different devices. It's like everything in distributed computing. Federated machine learning, it's different stuff. Okay, maybe this picture is not so informative, but the main difference is that it is possible to create machine learning algorithm which does not share data. We are doing the common machine learning, this is a figure in the right side, but all the node is keeping their own data for themselves. So, and this can be really game-changing stuff. Okay, since I am speaking in the section of research, so the typical measure how all this thing is interesting for researchers is number of papers. So let's look at Web of Science publications. This is some standard. So what we can say that everything started with cloud computing. Cloud computing as a scientific topic, saturated, and then we have some growing of edge computing, which appeared just in the real growth started in 2017, 2018, quite recently. But this is edge computing. If we are switching to edge machine learning, the growth is much faster and more recent. It just in 1920 started both edge computing, edge machine learning, and federated machine learning started to gather pace. Okay, so machine learning is the most often discussed case use for edge computing. And edge computing is going to be everywhere. We need a real time in augmented reality, in connected vehicles, in industrial IoT, as it was spoken before, smart cities, smart grid, smart health, and so on. So there are a lot of applications where we need real-time inference. And edge computing and edge machine learning is one of the main tools to achieve that. Okay, example, future e-health. Everybody of us have heard about wearable sensors, which can monitor our health system real time. The question is, how fast all this data collected from these devices and sensors can be used for making decisions. Because in health care, the time is critical. If we are speaking, for example, about heart conditions, time can make a difference between life and death. So it is obvious that distributed intelligence or local machine learning adapted for the person can be crucial here. And there are a number of technologies which are here. Some example how we can do it. We can make a model, or somewhere in a central facility, some model can be created, then it can be trained locally, and then it can be applied locally. This is some way of doing real-time applications for machine learning on the edge. Let's move a little bit about and speak about federated machine learning for e-health. The big issue for all e-health is question of privacy. There are a lot of regulations which does not allow hospitals or patients to share data about their patients. So from one hand, this is clear need to keep privacy. Some obvious reason is insurance companies. If everybody would know about my health conditions, it can be very difficult to obtain insurance. But there are other reasons why privacy in e-health care is important. Federated machine learning allows not only to train data from the hospitals without sharing it, but in the next step, we can even avoid any central authority. Some machine learning models can be created in some distributed way between hospitals. And so we do not need some central authority. I would say that here it sounds a little bit something like cryptocurrency. Yeah? It was some revolutionary idea that we do not need banks or central banks. So maybe we even do not need any health ministry or health authority. Okay, but this is too far. Okay, there are many challenges for federated learning. It is not that simple because we are having, for example, the data generated by different nodes, they will not be identically formatted, they will not be identically distributed, and it is difficult to have a data labeling. So a number of issues for federated machine learning is existing. But still, from my point of view, this is something where the biggest change can happen when we are speaking about machine learning on the edge. So again, from internet, edge machine learning is a most talked tech advancement since appearance of Internet of Things. Why? It's more or less clear, but what I would like to discuss for my final minutes is really edge machine learning revolutionary? Because what I was speaking about before, it's more or less okay, we need faster devices with better computing capabilities. We need better algorithms for deep machine learning, and so on and so on. We can do that in real time. Where is revolution? Is it revolution only in the scale that we will have machine learning everywhere? Of course, this is some kind of revolution, but that's all? Okay, so I would like to switch to my last points, that it is becoming to be clear that edge machine learning and edge processing of data can have a very big impact and revolutionary impact of the future of data. Because I will show you later, the biggest amount of data will be created on the edge. And as I was speaking about federated machine learning, the data can be kept private. We can use data for machine learning or for other purposes, and we can keep it private. We can define data ownership, and we can define data provenance. And so it's really something which can create in the future market for data. Okay, it was spoken a lot about a market of data. It was even created some kind of markets for databases, but it never took off because we need data standards and regulation. We need some, regulation to be able to create real market. Of course, one issue which moving data for this kind of market is politics. Because who owns data is having power. And nowadays, the biggest companies like Amazon, Google, or Facebook, they are collecting a lot of data. And not all governments are happy. I am not even speaking about China. So this is a big issue, and real democratic free market for data would be very nice way forward. And here comes European Union. European Union issued in 2020 European Data Strategy, saying that like Europe created GSM standard for mobile telephony, European Union created a standard for personal data protection, GDPR. European Union want to create some standard for data. And why? Because this is a prognosis from Gartner that in 2025, close next to 6% of GDP will be data, based on data. So data is starting to have a huge value for European Union. And what is more important, that it is not only becoming more and more important, the data, it will be generated on the edge. So what we are doing on the edge, how we are using the data on the edge, it will be crucial for the future data market in Europe and most probably in the whole of the world. And European Union is putting money where they want. We are promising to invest close to 6 billion euros during the next years for creating infrastructure for data management. This is both, not only on the edge, but also in the cloud infrastructure. But this shows that really data is becoming a very big economical issue. And I would like to stop here.
Thank you so much, Professor. Thank you so much for sharing really interesting data on your slides. I have a few questions that I'd like to explore together with you. Let's start with the first one. What do you think is needed for a bigger breakthrough in Lithuania in machine learning research and development?
Like everything on IT, we need people. We need trained people.
So the human capital is the problem.
Human capital, it's very difficult. We should produce human capital, and we should retain human capital. So that is a really big issue. A lot of is happening, but I think this will be the biggest bottleneck. The number of people able to deal with machine learning in Lithuania.
It's very interesting because my next question is, has COVID impacted the R&D in any case? And in this case, why do I want to ask this question? The thing is, actually, in many industries, COVID pandemic actually worked as a catalyst, as an enforcer of digital adoption, right? In people got used to actually operate, work, and live through the screens. And in this case, technology has no borders. And if we say, well, like we need, for example, more of human capital, so why don't we use the capital that is available across Lithuanian border?
Yeah, we should do that. I would say that we should do that. Of course, okay, I can say from perspective of a professor.
Yes, a few
Yeah.
cases, please. Few
Yeah,
cases.
yeah, no, but the point is that digital working, digital learning, digital living will not never be digital completely. We always need face-to-face communication. And nowadays we clearly see what are limitations of digital teaching. It's very nice as addition, but you cannot really make real teaching and studying fully digital, because human communication in person is something which is inherent for human beings. I hope so. Maybe in some years we will sit in our box and will not go out at all, but I don't believe that.
What's your perspective then on the VR and AR, augmented reality solutions? For example, we can already today, I think, to sit in the boardroom or in some hall and have a visualized person sitting next to us and acting. Of course, we will never have this sense of touching, right?
Who knows, maybe we will have.
Yes, so what's your perspective on this technology?
Okay,
Do you think it could be a breakthrough?
I don't think it will be a breakthrough. This is like the Zoom meetings. The Zoom meetings is a very nice thing, saving money and helping saving time, but if you are having something essential to discuss and decide, you immediately see that Zoom meeting is not a real tool for that. Because if you have sensitive things to discuss, you should see your partner. You see in Zoom your partner, but you don't feel it, what we are used to. Maybe we will be trained in some time to use Zoom as good as in personal meetings. But this does not look like. So my feeling is that even augmented reality, it will help us a lot. It will help us to solve many issues, but it will not be final, how to say, tool to making everything.
Absolutely. Professor, you're an expert on machine learning. What is that one or few solutions, or maybe the direction that the research is moving, that you're personally super excited about and you really want this to happen?
I excited very much with federated machine learning.
Okay.
Because my another, how to say, loved topic is cryptocurrencies.
Okay.
I do not have any Bitcoin.
I just wanted to ask, do you own any crypto?
No. But the technology behind Bitcoin for me is very exciting. This distributed trust is something really, okay, I could give you another talk about that.
Okay.
Next time.
Understood.
Yeah?
Understood.
But what I want to say that from my point of view, federated machine learning can do something like cryptocurrencies.
Amazing. Okay, and Professor, the last question. We have a lot of young people looking at us and watching our broadcast today. And what would be your advice if they're interested in machine learning? Where should they start their journey? What to read, look, or where to, I don't know, study? Just your own perspective. If, for example, we would be having a lot of young people interested in machine learning asking us, so what should I do next? What are the first steps?
Okay, a little bit depends how old they are, what they are going to do. First of all, I would say to go study. Mm-hmm. That's not important. It is not very important if it will be just a machine learning. But I think to study, you need to have a community of similar-minded young people. And you need some community of simple-minded professors and teachers. That is most important. How you can do that, this is up to you. But I can say that you cannot learn very well on internet. It is not enough.
Thank you for that.
Yeah,
Thank you for your
thank you.
answers, Professor. Thank you so much for your keynote presentation. Ladies and gentlemen, that was Professor Antanas Cenys from the Information Systems Department at Vilnius Gediminas Technical University. Let's move on to our next keynote speech.